traveller something quiet has begun moving through our sky. A detail most people will never notice, yet it has led you here at the exact moment this story needed you. You didn't arrive by accident. Something in the dark has been waiting for your attention. What if an object crossing millions of years of interstellar distance reached Earth on a 1 in 500 trajectory? What if a visitor that glowed behind the sun returned altered, carrying data our instruments still can't interpret? What if December 19th isn't about danger at all, but about witnessing a cosmic event that has never repeated in human history? A silent shape drifts beyond Mars, now steady watching. Stay with me. Let's go a little deeper. Something ancient drifts through our sky tonight, moving with a patience older than language, older than every civilization that ever looked upward and tried to name the dark. It comes from the space between stars where gravity loosens its grip and silence becomes the only stable truth. Astronomers call it Thrukiasuai Atlas, the third confirmed interstellar object to cross our solar system. But names are small compared to what it represents: a memory carved from another sun carrying the cold chemistry of a place we will never see. Its arrival is not an accident. Every orbit, every faint arc of motion carries the quiet logic of cosmic mechanics. Yet something deeper seems to unfold here, a sense that this moment has been waiting for us to notice. The two earlier visitors, Oumuamua in 2017 and Borisov in 2019, each broke open an era of re-evaluation. They taught us that the galaxy does not seal itself off from its neighbours. Instead, material drifts from star to star, from system to system, like seeds carried across continents by winds we cannot feel. But 3I Atlas does something neither of them did. It passes closer to Earth than any confirmed interstellar comet in recorded history. Not close in the human sense of distance, but close enough that our instruments can follow it with precision measured in minutes, not days. Close enough that the faint light it sheds, sunlight scattered off ancient ice, reaches us before fading into the background noise of the sky. It moved past the sun on October 29th, slipping through Perihelion in a corridor of radiation intense enough to strip fragile objects into dust. Many comets do not survive such an encounter. Heat fractures their surfaces, a vapour tears their cores apart, and they dissolve into tails that scatter like fine ash through the solar wind. But 3I Atlas endured. Multiple spacecraft caught glimpses of it during that passage. Mars orbiters, seeing it from a different angle of the inner system, traced its faint diffusion against the glare. Deep space probes. Lucy and Psyche turned their cameras toward it, capturing fragments of a story they were never designed to witness. Even SOHO, which spends its entire existence staring into the sun, managed to record the visitor, as it skirted the edge of visibility, contradicting predictions that it would be too dim to track. Then came the silence. During the weeks of solar conjunction, the comet slipped behind the sun from Earth perspective and vanished. Not by mystery, not by intention, but by geometry alone. No telescope could follow it. No observer could trace its arc. It was as though the universe placed a hand between us and the visitor, reminding us that observation always comes with limits. The solar corona swallowed every hint of reflected light, and all we could do was wait. Silence, after all, is the universe thinking, and sometimes the most honest form of understanding is simply allowing that silence to stand. When it emerged again in mid-November, astronomers turned their instruments toward the calculated coordinates, uncertain whether the object had survived. What they found were signs of endurance mixed with subtle change. Its tail structure had shifted, its brightness varied. The coma breathed more softly than before. Nothing dramatic, nothing sensational, just an object responding to heat distance and entropy the way all comets do. Yet for those watching with careful eyes, these changes carried significance. They were clues engraved in sunlight telling us about the structure of an interstellar body shaped around a different star under conditions we can only infer. As December approaches, 3I Atlas continues outward from the sun while drifting inward toward Earth's orbital position. Its path is mapped with exquisite certainty. The date of its closest pass, December 19th, arrives with the inevitability of a tide, And though the comet will still remain far beyond the Moon's orbit, its approach marks a moment without precedent. For the first time, humanity observes an interstellar object passing near enough that even small telescopes under the right skies might record its movement across the stars, not as a streak, not as a flare, but as a faint, steady presence. A visitor moving with the unhurried precision of a thing that has crossed light years to reach this point. This event is not about danger. It is not about collision or catastrophe. The distance ensures safety beyond any meaningful doubt. Instead, the moment matters because of what it reveals about our relationship with the galaxy. It shows us that we live inside a porous boundary, open to the drift of objects formed around different suns. This solar system is not a sealed chamber. It breathes, exhales, and receives. Somewhere beyond our reach, something ancient still moves, and 3i Atlas is one of the rare times we get to witness that motion passing through our own neighbourhood. Listener, all of this reminds us that understanding is never complete. We gather data, refine trajectories, analyse spectra, yet the deepest questions remain untouched. What shaped this object in its distant home? How long did it travel through interstellar darkness before falling into the sun's gravitational influence? What histories of heat and collision and chemical evolution lie frozen beneath its crust? Science offers methods, not finalities. And in this, there is peace. It's all right to not understand. The cosmos has always been larger than our certainty. As we follow 3i Atlas toward December 19th, the story becomes less about prediction and more about quiet observation. It asks us to slow our breathing, to release the need for conclusions, and to accept that witnessing is its own form of meaning. Every object that crosses our sky carries with it a fragment of a much older tale written in dust, radiation, and time. Tonight the universe whispers again, and the whisper is simple. Pay attention, but do not rush to answers. Let the moment unfold as it must. Let curiosity rise without urgency. Let the night teach you gently how to hold wonder without fear. The closer we look at 3 Atlas, the more it reveals the quiet architecture of a universe shaped by motion and entropy. Nothing in space is truly still. Even frozen fragments wander along currents carved by gravity, passing from one region of the galaxy to another with the patience of drifting ash. This comet's hyperbolic path confirms what astronomers suspected from the beginning. It is not bound to our sun. Its speed and angle of entry exceed what any native comet could sustain. It is a visitor travelling on a one-time trajectory through our system before escaping again into the wider dark. Every measurement reinforces this truth, yet the deeper meaning lies not in the numbers, but in the sense of transience they quietly express. Its journey through Perihelion offers one of the clearest windows into its nature. When 3i Atlas brushed past the sun on October 29th, it entered a realm where heat rises to extremes and solar radiation sculpts every exposed surface. Comets respond to this violence in different ways. Some flare brilliantly, their trapped ices vaporizing into spectacular tails. Others fracture into streams of debris undone by the same forces that once shaped them. 3i Atlas behaved with restraint. It neither erupted nor shattered. Instead, it persisted, shedding material slowly, following the physics of sublimation with an almost meditative steadiness. Its survival hints at internal cohesion structure strong enough to endure a star's relentless pressure without collapsing. A rare trait among comets, and perhaps a clue to its origin. Mars orbiters were the first to confirm this endurance, capturing faint images of the visitor from their vantage point in the inner system. These photographs, though subtle, offered something profound. They showed the comet not as a streak of drama, but as a soft persistence against the void. Lucy and Psyche followed with their own perspectives, slightly offset positions in deep space that added new angles for triangulation. These glimpses formed a constellation of observation, each spacecraft acting as an eye placed at a different point along the sun's vast perimeter. With each captured frame, the picture sharpened not into clarity but into deeper curiosity. Silence does not erase questions, it sharpens them. Then came the days when the comet passed behind the sun. Listener, this is where the story folds into stillness. During solar conjunction, even our most powerful telescopes lose sight of anything near the solar disk. not by mystery, not by omission, simply because light overwhelms everything near it. The sun does not hide secrets, it drowns them in radiance. For weeks, full-eye Atlas moved through a region where observation was impossible, following a trajectory we could predict but not verify. And in that interval, theories multiplied. Some whispered that the visitor had fragmented, others wondered whether its brightness had changed beyond expectation. Yet the truth was simpler. The universe had closed a curtain and all we could do was wait. Waiting is its own kind of instruction. In the absence of images, astronomers turn to models, to physics, to the quiet reliability of orbital mechanics. The predictions held. And when the comet emerged from conjunction in mid-November, it appeared almost exactly where calculations said it would. Slightly altered in brightness, its tail shifted by solar wind, its coma breathing differently but intact. Change without catastrophe is still change, and in the world of comets, subtle variations can carry entire histories encoded within them. Each filament of dust reflects its own journey through heat and distance, creating a tapestry of motion too delicate for the naked eye but unmistakable to the patient observer. Ground-based telescopes soon recorded more details. An ion tail blue faint, aligned with the solar wind, confirmed active outgassing. Dust structures hinted at rotation, uneven heating, and a nucleus shaped by a star we will never see. The presence of an anti-tail, a feature born not of physics, but of perspective, offered a reminder that reality often depends on where we stand. In astronomy, illusions reveal truths. When dust aligns with orbital planes, it creates shapes that appear to defy the laws governing tails. But this defiance is a matter of sightline, not substance. The universe rarely breaks its own rules. It merely invites us to learn them more carefully. By the time the visitor entered late November, astronomers had enough data to describe it with unusual confidence. Its speed, its angle, its trajectory, its rotation, the distribution of volatiles in its coma. Yet beyond all these measurable traits lay an unspoken understanding this object was shaped in a place profoundly unlike our own. The ratios of carbon-bearing molecules, the subtle balance of ices, the structural resilience all pointed to conditions not common in comets, native to the Sun's family. As though somewhere far away under a colder light or within a disk of different chemistry, this object slowly formed over millions of years before being cast into motion by an ancient gravitational encounter. Somewhere beyond our reach, something ancient still moves, and as 3-Eye Atlas drifts closer to its December path, that movement becomes our opportunity to witness what interstellar material looks like when illuminated by our Sun. It offers a glimpse into a region of the galaxy we cannot visit, a sampling of chemistry we cannot replicate, and a reminder that the universe does not separate itself into tidy compartments. Material wanders, stars trade debris, systems breathe each other's dust. We are part of that exchange whether we notice it or not. Traveller, this moment is a lesson in proportion. The comet cares nothing for our attention. It will follow its path whether we watch or look away. Yet our watching gives the moment meaning. Not because observation changes the object, but because it changes us. There is humility in realizing how brief our encounter will be, how small our window of understanding remains. And there is peace in accepting that some mysteries are not meant to be solved, only witnessed. Tonight the universe whispers again, and in that whisper lies the soft truth of part 2 that motion is memory, that light is language, and that even passing objects can teach us how to rest inside the unknown. The story of 3-Eye Atlas deepens as it moves outward from the Sun, and inward toward the place in Earth's orbit where their paths will come nearest. What we see now is not a simple comet following a predictable script, but a body shaped by forces older than our solar system. Every observation from spacecraft perspectives to ground-based spectra adds a new thread to a pattern we are only beginning to recognize. The visitor behaves like a comet in many ways, yet carries traces of a formation environment that differs from the one that shaped our own celestial debris. This dual nature familiar physics wrapped around unfamiliar history creates a quiet tension at the heart of every report. As astronomers refine their models, the hyperbolic trajectory becomes more than a mathematical curve. it becomes a reminder that most of the galaxy remains in motion far beyond the tempo of any single planetary system. Hyperbolic orbits tell stories. They speak of encounters long past where gravitational tides nudged objects from their birthplaces and cast them into the wider void. They mark the difference between visitors that return and those that do not. The Tree-Eye Atlas will not be captured. Its speed, its angle, its momentum, each element confirms its status as a wanderer passing through only once. There is a quiet grace in that singularity. The deeper scientists look, the more the object's composition becomes the centre of curiosity. Spectroscopy reveals the familiar signatures of water, vapor carbon monoxide, carbon dioxide molecules that define the behaviour of many comets within the Sun's family. Yet the ratios between them differ ever so slightly. Not enough to suggest something exotic, but enough to imply a birthplace shaped by different temperatures, different radiation, different dust environments. These details matter. They are the equivalent of dialects in the language of chemistry, soft signals that whisper of distant stars and ancient disks of gas and ice, where this object once formed. When astronomers discuss deviations in brightness or subtle shifts in tail shape, they are not seeking drama. They are listening to these signals. Dust jets expose uneven surfaces. Variations in brightness reflect the rotation of asymmetric structures. Each change is a message from a nucleus that has travelled for millions of years, enduring collisions, heating cycles, and the slow erosion of cosmic radiation. To witness these changes now is to read a fragment of its biography. Even the faintest variation is a clue about how its crust responds to the sun's energy, and how deep its more volatile layers lie beneath. Solar wind shapes the visitor as well. Charged particles stretch the ion tail into thin luminous strands pointing almost directly away from the sun. This alignment is a form of cosmic choreography. The tail does not choose its direction, it simply reveals the unseen flow passing through the solar system. At times, this tail appears to flicker or shift, abruptly a reminder that the solar wind itself is not constant. It pulses, surges, quiets like breath on a planetary scale. In these reactions, the comet becomes a kind of instrument playing out the patterns of a wind we cannot touch, but can measure through the language of motion and glow. The dust tail, broader and softer, offers a different kind of insight. Dust grains respond to sunlight, not magnetism, drifting into a curved plume that gives shape to the comet's path. Within that plume lie details about grain size density and the slow erosion of the nucleus. If the dust is fine, the tail appears smooth and wide. If coarse, it becomes more jagged and structured. Observers note variations from night to night, subtle adjustments that reflect the visitor's evolving state as it cools and rotates. Nothing here suggests danger. Instead, it reveals a living response to heat and distance, a natural adaptation that unfolds silently in the vacuum. Certain images show an anti-tail, a feature that seems to defy the rules of comet behaviour, but science has long understood this illusion. When Earth crosses the plane of a comet's orbit, the dust distributed along that plane appears to project forward, creating a tail that points toward the sun. This phenomenon does not break the physics of radiation or magnetism. It simply shows that perspective is a powerful force. What we see depends on where we stand, and the universe often reminds us that a shift in vantage point can transform confusion into clarity. The anti-tail is one more lesson in that quiet principle. As December draws closer, astronomers track the visitor's approach with heightened focus. Not because they expect surprises, but because opportunities like this are rare. Interstellar objects seldom pass near enough for detailed observation. Even with modern instrumentation and global networks of telescopes capturing high-quality data, requires coordination, precision, and clear skies. Every night brings a new chance to refine orbital parameters, detect faint jets, compare brightness curves, and adjust predictions. These observations taken together form a mosaic of understanding that future scientists will return to long after the visitor has vanished beyond our reach. Listener, this is where the story widens. We begin to see not only the comet, but ourselves reflected in the act of observing. Human curiosity has always stretched outward, reaching beyond the safe glow of our own star. We build instruments that extend our senses, algorithms that refine our interpretations, and questions that remain open long after the data settles. Some part of us recognizes that these interstellar visitors carry more than dust. They carry perspective. They show us how small we are and how much there still is to learn. And in that realization, there is a gentle humility that quiets the mind. As Thrias Atlas continues to drift along its hyperbolic arc, we recognize that most of its journey will remain unknown to us. We will witness only a thin slice of its passage weeks out of millions of years. The rest lies in darkness shaped by stars and empty expanses we will never map. Yet even this small window offers enough to deepen our sense of connection to the galaxy. To know that something formed far away under a light we have never seen now passes close enough for our instruments to measure. It is a reminder that boundaries in the universe are more permeable than we once believed. Silence surrounds the visitor, but is not a silence of absence. It is the silence of scale, of patience, of movements too large for urgency. And as we watch it cross the inner solar system, we begin to understand that this passage is not an event meant to alarm or amaze. It is simply a moment of cosmic continuity, one traveller drifting past another, neither intruding nor threatening, only passing through. Tonight the universe whispers again, and the whisper asks nothing of us but awareness. As 3 Atlas moves farther from the sun, its path becomes clearer, yet its meaning grows more complex. We learn more about its structure with every observation, but the growing knowledge does not erase the sense of mystery surrounding its origin. In fact, the more precise the measurements become, the more apparent it is that this visitor formed in an environment distinctly unlike our own. The differences are subtle, written not in dramatic signals, but in the quiet proportions of molecules, in the endurance of its nucleus, in the way its dust behaves under solar influence. Each clue points to history, stretching far beyond our solar system's borders. Spectroscopic analyses reveal signatures that match much of what we know from local comets, yet the ratios differ just enough to suggest a different birthplace. Comets carry records of their origins in their frozen layers, records shaped by temperature radiation and the chemistry of their home star's protoplanetary disk. 3i Atlas holds those records, tightly releasing them only when heated by sunlight. As the sun warms its surface, the gases escaping into space tell a story millions of years old. And while the story feels familiar, it is unmistakably written in a dialect from beyond our sky. The tale continues to shift and breathe, responding to the solar wind with the grace of something shaped by physics alone. The ion tail, thin and delicate, stretches outward, tracing invisible flows of charged particles that sweep through the inner system. In contrast, the dust tail spreads into a broader plume, reflecting sunlight in ways that reveal the distribution of grains born from slow erosion. These structures are not static. They evolve nightly, responding to the visitor's rotation and the ebb of heat across its terrain. Each subtle change becomes a note in a longer composition, a record of the journey unfolding in real time. As astronomers gather images from multiple hemispheres, parallax provides the depth our eyes cannot. A comet seen from one vantage point appears as a simple smear of white, but combined views from distant locations and its true position emerges with remarkable clarity. These measurements refine the trajectory, confirming again and again that the visitor's motion remains consistent with a hyperbolic escape. It entered our system once. It will leave once. There will be no return. This understanding lends a gentle weight to every night of observation. The opportunity is fleeting, and the universe rarely offers second chances with objects like this. In the wake of solar conjunction, questions arise not about the comet's safety, but about the limits of human perception. When 3 Atlas disappeared behind the sun, it reminded us that even with advanced instruments scattered across the sky, there remain angles we cannot reach. Geometry still sets boundaries. Light still blinds. Silence still prevails in places where heat overwhelms every instrument. Yet within that limitation lies a quiet lesson. Not every gap in data is a sign of the unknown. Some are simply the natural pauses built into the architecture of observation. When the visitor emerged right where predictions placed it, the universe affirmed what mathematics already knew. Despite the stability of its orbit, the visitor's brightness remains difficult to predict. Comets are notoriously unpredictable in their light curves. A small change in rotation can expose new patches of ice, causing temporary brightening. A crust of dust may inhibit sublimation, dimming the coma unexpectedly. These fluctuations hold no danger, but offer insight into the physical structure beneath the surface. In a way, brightness becomes a heartbeat. It pulses in response to sunlight, revealing where energy flows and where it does not. And as 3 Atlas drifts farther from perihelion, that pulse softens into a steady decline marked by cooling contraction and the slow retreat of its activity. Ground-based telescopes continue to record the anti-tail, a feature born from alignment rather than anomaly. When Earth's position intersects the plane of the comet's orbit, dust lays out before us, like a thin sheet illuminated at the edge. It appears to point toward the sun, defying intuition, but the physics remain intact. Perspective bends perception, not the laws governing matter. These images remind us that the universe does not always present truth directly. Often truth must be reconstructed through understanding, not merely sight. This phase of the visitor's journey becomes a living example of how science adapts. Missions like Lucy and Psyche were never intended to study interstellar comets, yet their instruments now contribute invaluable glimpses. Telescopes worldwide adjust schedules, seizing windows of opportunity created by weather rotation and seasonal angles. Amateur astronomers capturing long exposures from quiet hillsides add frames that professionals use to confirm models. Knowledge emerges not from a single source, but from a network, an ecosystem of attention grounded in shared curiosity. In this sense, 3i Atlas unites observers across the world, linking distant points of the planet through one object drifting through the dark. The mathematical certainty of the comet's path reveals something more subtle. The solar system is not static. Every visitor alters the balance, however minutely. Dust from this object will disperse along its trajectory, joining the vast population of particles drifting through interplanetary space. Gravitational interactions, though extremely small, will shift positions on timescales far beyond human lifetimes. Even a traveller passing at a great distance leaves a trace not dramatic, not visible, but part of the ongoing evolution of the solar system. In this sense, every interstellar visitor becomes a participant in the subtle shaping of our cosmic home. What stands out most now is the calmness of the motion. No sudden jets redirect the orbit. No fragmentation clouds bloom into unexpected fields. Everything unfolds with the precision predicted by physics. If the universe is speaking through this object, it speaks in a quiet voice, one that affirms stability rather than chaos. The visitor behaves not as an intruder, but as a guest passing peacefully through a vast shared space. Its presence invites reflection more than analysis, stillness more than speculation. Tonight the universe whispers again. The whisper carries no urgency, only the soft recognition that we are witnessing something rare, something shaped, across distances we cannot travel. And in that passing moment of awareness, we feel our place within a larger system that moves steadily, patiently beyond the boundaries of our understanding. As December draws nearer, the conversation surrounding 3i Atlas continues to shift from simple observation to deeper contemplation. What began as an astronomical event gradually expands into a study of limits. Limits of measurement, limits of interpretation, limits of what can be known during such a brief encounter. The comet becomes a mirror for our methods. Its steady motion tests the precision of our models, while its subtle variations expose the places where prediction and reality diverge. In this quiet tension between certainty and uncertainty, something profoundly human emerges. One of the most persistent questions concerns whether the comet's trajectory shows anomalies. Some voices far from professional circles speculate about unexpected motions or accelerating forces, but these ideas soften the moment we examine the data. The path of 3i Atlas remains exquisitely predictable. Observations align with gravitational models to a degree that leaves little room for doubt. Any outgassing effects are within the range expected from a modestly active comet. Its orbit does not twist or jump. It simply follows the direction determined by entering the solar system at high speed. Hyperbolic objects obey the sun's gravity in clean arcs, and this visitor is no exception. Still, the fascination persists, not because the comet behaves strangely, but because it behaves consistently, in a universe where mystery often hides in plain sight. Stability too can feel uncanny. There is something compelling about watching a body move through space without deviation, as though shaped by a logic older than any star map we have drawn. Its motion carries the discipline of deep time, the momentum of ejection from another stellar system long before Earth existed. To witness that momentum play out now under our own sun's influence invites reflection on how much of the cosmos lies beyond our control, yet still follows principles we understand. A separate question arises regarding composition. When scientists analyse the coma, they find familiar molecules, water, vapour, carbon monoxide, carbon dioxide, yet arranged in patterns slightly distinct from local comets. These differences are subtle, not enough to suggest anything extraordinary, but enough to confirm that 3 Atlas was shaped under different conditions. Comets are products of their birthplace. They hold the dust of childhood environments, the chemistry of early disks surrounding newborn stars. In this sense, an interstellar comet becomes a message from its origin system carrying a sample of temperatures, radiative environments, and elemental abundance ratios that prevailed far from our own. The comet does not need to be unusual to be valuable. Its ordinary behaviour becomes extraordinary because of where it came from. Even minor differences in composition become profound when traced back to a different star. The quiet presence of ices forged in another corner of the galaxy speaks to a shared history of formation among planetary systems, as though distant stars follow similar blueprints. At the same time, the specific ratios that differ hint that variation is universal, that no 2 systems craft their objects in exactly the same way. This delicate balance between similarity and deviation is a reminder that diversity in the cosmos is not the exception, but the rule. In discussions about visibility, brightness predictions highlight another truth: comets rarely obey expectations. A visitor predicted to brighten steadily may dim at the last moment, while another expected to fade may undergo sudden outbursts, illuminating itself with jets of newly exposed ice. For 3 Atlas predictions lean toward faintness perhaps remaining out of reach for most unaided eyes. But faintness does not diminish meaning. Some of the galaxy's most important lessons arrive quietly. What matters is not how bright the visitor appears, but what its presence reveals about the environment beyond the sun's reach. Brightness curves also serve a deeper scientific purpose. By tracking how light output changes, astronomers learn what kinds of volatiles dominate the surface. Rapid brightening suggests exposed ices reacting vigorously to sunlight, while a slower decline may indicate a crust insulating deeper layers. Even a small deviation from expected patterns helps refine models of interstellar comet behaviour. In this way, faintness becomes a teacher. The object does not need to flare dramatically to offer insight. It only needs to continue existing long enough for its behaviour to unfold in measured time. Another theme woven through scientific dialogue concerns the limits of threat assessment. Many people, upon hearing the words interstellar object, instinctively wonder whether danger is possible. But the numbers eliminate this concern. The distance at closest approach exceeds even the furthest reaches of lunar orbit. Gravity will not waver. Earth's path remains unchanged. The comet will pass as a distant whisper, not a striking event. That certainty frees observers from fear and allows them to focus on meaning rather than alarm. When understood correctly, the event becomes an invitation to look outward without anxiety. In embracing this perspective, December 19th transforms from a moment of concern into a moment of awareness. The comet becomes a reminder that not everything approaching Earth carries threat. Some arrivals carry knowledge instead. Some simply pass through, offering perspective before returning to the deep. In this way, 3i Atlas acts as a quiet counterweight to narratives of fear. It shows that cosmic encounters can be gentle. It restores the understanding that most of the universe is not aimed at us, but merely moving along its own path. As the date approaches, attention shifts toward what closest approach allows us to observe. This is not an event marked by spectacle, but by clarity. At that distance, sensitive telescopes can gather spectra, refine measurements, and deepen understanding of interstellar chemistry. Observatories will point their mirrors upward, not expecting unexpected fireworks, but seeking consistency, small changes in brightness, tail curvature, and coma evolution. that tell the true story of a visitor cooling as it moves away from the sun. For the broader public, the significance is quieter, but no less meaningful. The awareness that a body formed around another star will glide past our homeworld brings a rare sense of connection to a much larger system. It reminds us that Earth does not drift alone through silence, but participates in a cosmic exchange stretching across distances we can scarcely fathom. To know that something forged under a distant light now passes near enough for us to witness, even faintly, becomes a moment of shared humility. Tonight, the universe whispers again. And this time, the whisper suggests a gentle truth. Sometimes the rarest encounters are not loud or dramatic, but soft, distant, and quietly sufficient to widen our sense of where we belong. As 3I Atlas continues its outward climb from the sun, astronomers turn more attention to the way its coma evolves. Comets breathe in slow cycles. Warmth ignites them, distance quiets them, and somewhere in the middle, the transition reveals truths about their internal structure. After perihelion activity begins to subside, releasing the last meaningful pulses of gas before cooling reshapes the surface. Observers note how the visitor's coma has tightened its edges, becoming sharper as dust production decreases. This restraint carries no surprise. It is the expected rhythm of a body moving away from the heat that once stirred it. Yet within that predictable fading lies an opportunity to understand how an interstellar nucleus reshapes itself under our sun's influence. The ion tail offers another window into the comet's changing state. Near perihelion, the tail was long and responsive, shifting with every nuance of solar wind. Now, as activity declines, the ion tail thins. Its colour softens. The traces of carbon monoxide emissions weaken as fewer molecules escape the nucleus. In these changes, astronomers see the cooling process unfold in real time. The solar wind continues to sculpt the flow of charged particles, but the supply becomes smaller with each passing day. The tail's gradual withdrawal marks the visitor's slow retreat from the sun's energy. What remains visible tells the story of lingering heat. What fades tells how efficiently the nucleus seals itself against further loss. Dust too begins to settle into calmer behaviour. Dust tails are shaped by radiation pressure, not magnetic fields, and thus their evolution reflects the gradual lowering of sublimation rates. In the early stages, dust spread in broad fan-like arcs, catching sunlight in shimmering sheets. As activity softens, the dust tail narrows. Larger particles dominate, drifting more slowly, less influenced by the dwindling gas pushing them outward. At this stage, astronomers begin estimating the size distribution of grains released throughout the comet's passage. These estimates help reveal whether the object has a crust thick enough to insulate deeper layers, or whether its surface erodes readily. Each observation becomes a small piece of an interstellar puzzle. Through this period, telescopes continue to track the visitor's brightness, noting how it declines in uneven steps rather than a smooth curve. Comets rarely fade uniformly. Their surfaces contain patches of volatile, rich material mixed with areas that resist sublimation. As sunlight falls across the rotating nucleus, different regions activate briefly before receding again into shadow. This variation produces fluctuations in light output that, when analysed carefully, reveal the approximate rotation rate. For 3I Atlas, the rotation appears slow, lending the object a quiet dignity as it drifts along its hyperbolic arc. Slow rotation reduces stress on the nucleus, explaining in part why it survived perihelion in such stable form. In the midst of this scientific work lies another curiosity: how the visitor responds to the shifting geometry between Earth and Sun. As the angle changes, the appearance of the tail alters subtly, not because the comet itself behaves differently, but because our vantage point evolves. Observers witness new perspectives, compressed tails, extended silhouettes, hints of curvature that only become visible when illuminated from particular angles. These shifts remind us that astronomy is never entirely objective. It is always filtered through position. Even a consistent object can look transformed when seen from a new place. This interplay between external behaviour and internal interpretation shapes much of what astronomers learn during close approaches. Some of the most valuable data now comes from coordinated campaigns, blending professional observatories with high-quality amateur images. In many regions, amateur astronomers capture scenes during hours when large telescopes remain occupied with other targets. Their long exposure photographs fill gaps in temporal coverage, allowing scientists to trace subtle changes with greater continuity. This shared effort reflects the modern era of astronomy, distributed, flexible, and deeply collaborative. A faint smudge on a backyard telescope sensor can become part of a global dataset documenting an object from another star. The quiet democratization of observation turns the sky into a collective endeavour. As the comet approaches its December moment of nearest alignment, astronomers revisit the mathematical foundation underpinning the predictions. Orbital calculations reinforce what has been known since early tracking. The visitor's path poses no threat. Its direction is clean, its motion steady. Even with outgassing taken into account, no significant deviations appear. This certainty allows attention to shift toward understanding rather than reassurance. When fear recedes, curiosity expands. The event becomes not a matter of risk but of perspective, an opportunity to refine models of interstellar object behaviour and to compare this visitor to those that came before. One question that continues to surface in scientific circles concerns how interstellar comets differ structurally from local ones shaped within our Sun's domain. The endurance of 3I Atlas through Perihelion hints at a nucleus more cohesive than many solar system comets of similar size. Cohesion can come from varied factors, internal layering chemical composition, or a history of collisions that compacted the body rather than fracturing it. Interstellar history remains invisible, but behaviour becomes its proxy. The visitor's resistance to fragmentation tells us that the forces which shaped it favoured stability. This stability becomes a gift, allowing extended observation that a weaker nucleus could not provide. The deeper meaning of this moment lies in the recognition that we are watching a body forged under a different star slowly withdraw from ours. Its fading coma becomes a kind of farewell, not dramatic, but gradual, as though written in a language of light and motion. The hyperbolic trajectory ensures that once this object leaves our observational reach, it will not circle back. It will continue outward past the planets beyond the orbit of Neptune and into the cold corridors where sunlight weakens to a whisper. Eventually it will slip into the realm where the sun is merely another star among many, its influence softened by distance. As 3 Atlas moves away, the sky teaches its quiet lesson: not everything that enters our lives remains. Some things approach, reveal a fragment of truth, and depart again without altering our path. Yet their presence changes how we see the world. The comet's brief passage through our solar system becomes a reminder that the universe is in constant exchange. Material drifts between stars, histories overlap without touching, and we caught in the middle witness these crossings not as endpoints, but as chapters in a longer story of cosmic movement. Tonight the universe whispers again, not with certainty or urgency, but with the soft acknowledgement that even fleeting encounters can deepen our understanding of where we stand in the vastness. As 3 Atlas moves into the final stretch before its closest passage, attention turns toward what this moment offers rather than what it threatens. With danger long dismissed, the lens shifts toward meaning, what can be learned, what can be clarified, and what quiet impressions the visitor leaves behind as it crosses the sunlit interior of our system. The days leading to December become less about anticipation and more about refinement. Refining measurements, refining expectations, refining the understanding that this encounter represents a rare alignment of timing and opportunity. During this period, global observatories adjust their schedules to secure every possible window of visibility. Not because the comet behaves unpredictably, but because the instruments that track it must contend with weather, atmospheric turbulence, and mechanical constraints. Each night becomes a negotiation between clarity and cloud, between Earth's shifting conditions and the comet's steady motion across the starfield. The visitor offers consistency, the sky does not. Yet within that inconsistency lies a kind of intimacy. Observers take what the atmosphere gives, capturing fragments that when combined across continents reveal a coherent story. The Virtual Telescope Project and similar initiatives prepare for live observations, allowing thousands of people to witness the passage even if they lack equipment or favourable skies. This democratization of the moment transforms the event from a technical occurrence into a shared experience, It shifts the tone away from exclusivity and toward inclusivity, allowing anyone with curiosity to join the unfolding dialogue. The comet becomes not only a scientific target, but a quiet bridge linking distant observers through a single point of interest drifting far beyond their reach. What will actually be seen on December 19th remains modest. A faint object, slightly elongated, moving slowly and almost imperceptibly against the background stars. The human eye will not perceive motion in real time, only through careful comparison of images will the shift appear. This subtlety challenges expectations shaped by dramatic depictions of comets streaking across the night sky. 3i Atlas carries no such spectacle. Its impact is quieter, built not on brightness but on origin. The idea that something formed around another star now drifts within the range of our instruments remains the true source of wonder. Astronomers expect the comet's brightness to continue declining as cooling deepens. Yet even this decline holds value. A fading object allows scientists to better understand how interstellar ices behave at different distances from the Sun. As the nucleus cools, gas production slows, exposing the interplay between crust heat and sublimation. These processes, though subtle, reveal the thermal behaviour of material shaped beyond our solar system. Observing these shifts over the days surrounding closest approach provides data that would otherwise require missions far beyond our current technological capabilities. More intriguing are the structural changes expected in the tail. As the comet angles away from the Sun, the geometry of light scattering changes. The dust tail may appear narrower, the ion tail may stretch into thinner, straighter lines. These adjustments will not mark new behaviour, but rather new perspectives. A comet does not change for the observer changes position relative to the comet. This truth mirrors broader astronomical practice. Understanding emerges not from a single angle, but from the synthesis of many. As interest builds, questions begin to shift toward the deeper implications of such visitors. 3 interstellar objects in less than a decade challenge the earlier assumption that these encounters are rare. Instead, they suggest that interstellar space contains far more drifting material than previously believed. Our solar system is not an isolated sanctuary. It is a region through which foreign objects pass regularly on timescales, longer than any human lifetime but shorter than cosmic memory. Each visitor becomes evidence of a galaxy far more connected than imagined, a place where systems share fragments of themselves through gravitational exchange. This recognition changes not only scientific models, but philosophical reflections. The boundary between stellar systems becomes porous. Material travels freely, shaped by chance encounters and ancient ejections. Comets like 3i Atlas become ambassadors of sorts, carrying frozen records of processes occurring light years away. Their passages are short, but their message endures. The universe is not arranged in closed compartments. It flows, shifts, exchanges, adapts. And we are part of that cosmic ecology, both observers and participants. As December approaches, the sense of finality gently settles into the narrative. The closest approach marks not an end, but a midpoint. After the date passes, the comet will continue outward, cooling further, fading faster, and eventually slipping beyond the grasp of even the most sensitive telescopes. Yet the days before closest approach remain some of the richest scientifically. They offer a last concentrated opportunity to compare predictions with reality, to refine the physical profile of the visitor, and to observe the gradual transition from active object to dormant traveller drifting back toward interstellar space. Tonight the universe whispers again, not through brightness or spectacle, but through the steady presence of an object that reminds us how wide the galaxy truly is. There is no urgency in its motion, no call to fear, only a quiet invitation to witness a moment that will not repeat a gentle crossing of paths between our world and something shaped under a distant light. As the comet draws nearer to its moment of closest alignment, astronomers begin preparing the final observational sequences. The days surrounding December 19th are not expected to bring abrupt changes, yet they hold a quiet significance. This is the window when the visitor's angle, distance and illumination reach a combination that allows measurements impossible at any other time. In astronomy, subtle convergence can matter more than spectacle. A faint object at the right distance may reveal more truth than a brilliant one at the wrong angle. Ground-based observatories will monitor the coma's temperature and density, watching how the sunlight glances across its diminishing activity. By this stage, most of the volatile material closest to the surface has already escaped. What remains is slower shaped by deeper layers still adjusting to the sun's influence. The rate of fading becomes a clue. A rapid decline suggests a thin crust and shallow volatile pockets. A slower, steadier decline hints at a more complex structure, where the thermal wave penetrates deeper before stabilizing. Either behavior teaches something about the comet's internal architecture. Attention also turns to spectroscopy. Even faint comets release light in characteristic wavelengths, revealing the chemical footprints of their ices and dust. These signatures shift subtly as the comet cools. Ratios change, intensities drop. The evolution of these spectral patterns in the days around closest approach becomes a miniature timeline of the visitor's transition from active to dormant. Scientists examine each shift closely, comparing them to data from local comets. Through these comparisons, the differences between interstellar and solar system formation environments become clearer. Some of the most delicate observations involve the dust tail. When sunlight strikes dust grains, their reflective patterns offer hints about size, shape, and composition. As the comet cools, the distribution of grain sizes changes to larger. Grains dominate because smaller ones disperse early in the process. These differences alter how the tail interacts with sunlight. Toward mid-December, images may show the dust tail appearing more slender or more uneven. These effects are not dramatic, yet they allow astronomers to refine models of dust ejection for bodies formed far from our sun. Even the ion tail, though fainter now, remains a valuable tracer of solar wind interactions. The tail's alignment shifts with each rhythm of charged particles flowing from the sun. By studying these patterns in the days surrounding closest approach, scientists gain a dual perspective insights not only into the comet's gas productions, but also into the solar wind itself. In this way, the visitor becomes both student and teacher, shaped by solar forces while revealing those forces through its response. Amid these scientific efforts, the public experience remains more contemplative. The comet will not blaze across the sky. It will not brighten into a naked eye display. Most observers will perceive it only through telescopes or shared live streams. Yet this quiet presence carries its own resonance. There is meaning in knowing that a body formed under a different star now passes within the range of our instruments. Not close in a visceral sense, but close in a conceptual one, close enough that humanity can measure it, describe it, and mark its passage with intention. This awareness transforms December 19th from an astronomical coordinate into a moment of perspective. It reminds us that the solar system is not sealed. Objects drift in, offer a glimpse of their histories, and drift out again. No message is declared, yet the presence itself becomes a message, a reminder that the galaxy is a place of motion exchange and quiet connection. Every encounter, however faint, expands the sense of what it means to live in a system open to the wider cosmos. As the comet approaches the date marked on ephemerides worldwide, a soft stillness enters the narrative. Nothing sudden is expected. No event will unfold in a way the unaided eye can grasp. Yet the simplicity of the moment becomes part of its beauty. A visitor from another star system reaches its nearest point to Earth, passes silently through the darkness and continues onward. The sky changes only by a fraction, but our understanding expands in ways that linger long after the object fades. Tonight the universe whispers again, gently, steadily reminding us that even the faintest passages can widen our sense of belonging in the vastness. As December 19th approaches, the focus shifts from the comet itself to the broader environment through which it passes. Observing 3-Eye Atlas becomes a study not only of a single interstellar visitor, but of the solar system's ability to receive and interpret such rare messages from the wider galaxy. Each night of data adds context to a larger truth: interstellar space is not empty. It is populated by drifting remnants from countless planetary systems, fragments cast off by gravitational encounters, collisions, and slow ancient processes that shape stars and worlds across cosmic time. The visitor's passage reminds us that the solar system exists within a dynamic, permeable environment, one that exchanges material with regions far beyond its borders. Astronomers examining cometary behaviour note that 3 Atlas now follows the expected decline in thermal activity, yet small intermittent flares still appear in certain measurements. These do not signify danger. Instead, they reflect the irregular terrain of the nucleus pockets of volatile ices that release gas as the sun's warmth reaches deeper layers. Such events are fleeting but instructive. They reveal the uneven surface history of the object, hinting at fractures, buried cavities, and complex layering shaped by slow accretion in an ancient disk of dust surrounding a long-lost star. To observe a flare is to glimpse a moment of memory heat unlocking a piece of the visitor's distant past. Meanwhile, the orbital calculations remain steady. The comet continues along its hyperbolic trajectory, with no deviations beyond the slight non-gravitational forces expected from outgassing. This precision reinforces confidence in the models predicting its path. For astronomers, stability is not mundane, it is beautiful. It affirms the reliability of celestial mechanics, a language through which the universe expresses structure and intention. A consistent orbit becomes an anchor of understanding as reassuring as the rhythm of tides or sunrise, even when applied to an object from beyond our own sun's domain. As the visitor nears the point of closest approach, the geometry of observation becomes increasingly significant. Earth's rotational and orbital motion alters viewpoints night by night, offering shifting angles from which to see the coma tail and subtle asymmetries in brightness. These variations allow scientists to construct a more complete three-dimensional model of the comet's structure. The changing perspectives act almost like a slow scan, revealing features impossible to discern from a single viewing angle. Through this process, the sky becomes a vast laboratory, using distance and time to grant insights that instruments alone could not achieve. Across observatories, one phenomenon draws particular interest: the comet's response to solar wind fluctuations. Spacecraft positioned throughout the inner solar system detect subtle changes in the charged particle environment. These changes ripple outward, and within days their influence becomes visible in the shifting shape of the ion tail. For researchers, such interactions provide a natural experiment. They illustrate how interstellar objects react to the solar system's unique electromagnetic conditions shaped by the sun's magnetic field, rotating patterns and seasonal variations within heliospheric flow. In the comet's tail, scientists read not only the story of its composition, but also the story of the solar wind itself. While professional astronomers interpret these details through precise measurements, many others simply reflect on the larger significance of the event. The passage of an object formed around another star evokes a sense of continuity across the galaxy. It suggests that planetary systems everywhere experience periods of creation, destruction, and release. Comets, asteroids, and icy fragments drift outward when gravitational forces push them beyond their local spheres. Over millions of years, these fragments become travelers through interstellar space. Some never encounter another star. Others, like 3I Atlas, eventually fall under the subtle influence of a distant sun entering a new environment before continuing their journey. This exchange serves as evidence for a galaxy governed by interaction rather than isolation. Stars are born in clusters, share material during formation, and later scatter debris across vast distances. The boundaries between systems are not walls, but transitional zones where gravity shifts allegiance. In these liminal spaces, objects drift from one star's influence to another's. Observing one such object from Earth becomes a reminder that the solar system participates in the same long cosmic cycles as every other star. It receives and releases material, contributing to the quiet exchange that shapes the galaxy over eons. Within scientific circles, the increasing detection rate of interstellar visitors prompts discussions about what future surveys may reveal. If 3 such objects have been observed within 8 years with instruments of limited sensitivity, how many more pass unnoticed at greater distances or fainter brightnesses? The answer is likely vast. The galaxy may be filled with rocky and icy fragments wandering between stars, each shaped by its own history, each carrying unique chemical signatures. With upcoming survey telescopes, especially those designed for rapid, wide-field scanning, the number of detected interstellar objects may increase dramatically. Their diversity will offer new windows into planetary formation across the galaxy. 3I. Atlas thus becomes part of a broader scientific shift. It is not only an event, but a reference point, a data-rich example of what interstellar comets look like when they pass within observational range. Its behaviour composition and endurance help refine expectations for future detections, and those future detections may help answer fundamental questions. How do planetary systems evolve? What conditions lead to the formation of ices and dust? And what variations exist across the galaxy's many stellar nurseries? As the comet approaches the threshold of closest passage, calmness settles over the narrative. Nothing dramatic is expected, yet the significance remains profound. A visitor from another star system passes near Earth not with fire or threat, but with quiet clarity. It offers no message, declares nothing, imposes nothing. Instead, it invites a shift in perspective, a recognition that our solar system is part of a much larger web of motion and exchange. Tonight the universe whispers again, reminding us that even the faintest encounters can reveal the vast interconnected structure of the galaxy we call home. As the comet approaches the moment of closest alignment, the atmosphere within observatories worldwide becomes one of focused stillness. Years of training allow astronomers to work with precision, yet the presence of an interstellar visitor adds a quiet gravity to every calculation. The measurements taken now in these final days before the pass represent the most detailed information humanity will ever gather about this object. Once it recedes into the outer darkness, no instrument will be able to recover the vanished details. This sense of finality does not add urgency, it adds meaning. The work becomes a quiet act of witnessing. Closest approach does not bring dramatic change. The comet does not speed up, brighten, or shift behaviour in any unexpected way. Instead, the most interesting changes are geometric. Earth's position relative to the visitor allows observations that highlight previously unseen aspects of the coma and tail. At certain angles, the dust appears more compact. At others, it stretches into a thin beam. These shifts reveal nothing mystical. They simply represent the interplay between sunlight rotation and our own movement through space. Yet within this interplay are clues about structure that only these few days can reveal. During closest approach, long exposure photographs capture the comet's motion across the background stars. Each sequence taken hours apart forms a subtle arc. The movement is not dramatic but slow and patient, mirroring the ancient origins of the object itself. These sequences become records of a passage no one will ever see again. They show the visitor as it intersects a tiny fraction of its path through the galaxy, a moment that for us appears significant, but for the comet itself is merely another point in a journey spanning millions of years. Even so, the images hold emotional weight. They remind us how brief our encounters are with objects shaped by other suns. Spectroscopy, during this window, becomes especially valuable. With the comet nearer than at any other time, the signals received by telescopes grow slightly stronger. Not bright, but sufficient. Scientists examine the fine details of emission lines tracing the proportions of different gases released from the nucleus. These signals often weaken as the comet cools, yet the clarity of measurement improves because of proximity. Even faint data holds a richness that broadens understanding. Through these observations, scientists refine models of molecular ratios, comparing them to solar system counterparts. Each numerical difference becomes a whisper of the environment where this comet first took shape. Observatories also monitor the ion tail closely during this period. Solar activity fluctuates at times, intensifying the stream of charged particles flowing outward. When these fluctuations occur near closest approach, the tail may react twisting slightly or forming a faint kink downstream. Such features help scientists map the texture of the solar wind, revealing how interstellar bodies respond to electromagnetic conditions within our system. The visitor becomes a tracer particle on a vast scale, illuminating the invisible forces moving through space around Earth. Even the smallest alteration in tail shape carries information about the dynamic environment shaped by the sun. The dust tail behaves differently, reinforcing its role as a marker of radiation pressure rather than charged forces. As cooling deepens, dust production declines. Larger particles dominate, drifting away more slowly. In photographs, the tail appears less diffuse, more defined. These changes reflect the natural fading of activity. the quiet settling of a process that once roared with sublimation near perihelion. Scientists study these transformations to estimate the size and structure of dust grains ejected earlier in the comet's passage. In this way, even the act of fading becomes a source of knowledge. Beyond the scientific realm, many observers find themselves contemplating what this moment represents. The comet will pass at a safe distance, barely perceptible without assistance, yet the simple knowledge of its presence brings a quiet resonance. There is something grounding about knowing that a body forged around another star has come close enough to our world to study. Its faintness does not diminish its significance. If anything, the absence of spectacle encourages reflection. It invites a gentler, more contemplative sense of connection, one shaped not by awe alone, but by perspective. The night of closest approach comes without fanfare. In most places, clouds pass without regard for the event. Cities glow with artificial light. People continue their usual routines. Yet across the world, scattered observers turn their cameras upward, capturing faint arcs of motion, subtle shifts in brightness, and the delicate geometry of dust and gas shaped by solar forces. The comet itself remains steady, unchanged by human attention. It passes quietly unaffected by the weight of meaning placed upon it, and in that indifference lies a soft truth. The universe does not require our awareness, yet our awareness deepens our sense of belonging within it. In the hours after closest approach, data continues to flow. Observatories refine their models, comparing predictions to observations. The match is strong, reinforcing confidence in the physics underlying the comet's path. This consistency reassures scientists that interstellar objects, for all their distant origins, still obey the same laws that govern local bodies. The visitor becomes a testament to the universality of physical principles. Motion, gravity, light and heat shape all objects regardless of the star that first warmed them. As December 19th fades into memory, the comet begins its gradual retreat. Its light weakens, its coma contracts, its tail thins into faint threads before dissolving against the black. The visitor's presence becomes a story told in data images and quiet reflections. Yet the fading does not diminish the significance of the moment. It simply completes it. The comet continues onward, unbound, returning to interstellar space, and we remain with the understanding that even brief passages can shape how we see the galaxy. Tonight, the universe whispers again, softly, steadily, reminding us that closeness is not measured by brightness, but by attention, and that even the faintest visitor can leave a lasting trace upon the mind. In the days following closest approach, the comet enters a quieter phase of its passage. Though still within the reach of telescopes, its brightness begins to drift downward, softened by increasing distance and diminishing heat. The coma contracts becoming sharper and more defined as activity subsides. This transition marks the beginning of departure, a process as slow and deliberate as the arrival that preceded it. Nothing sudden occurs. Instead, the comet settles into the gentle slope of cooling, fading a little more each night. In these subtle changes, astronomers find the closing pages of a story months in the making. As the visitor retreats, telescopes continue to monitor its spectral signature. The ratio of gases shifts in predictable ways. Carbon monoxide persists longer than water vapour, hinting at deeper layers still releasing remnants of ancient ice. Carbon dioxide declines more quickly, reflecting a surface that has already surrendered much of its volatile content. These changes offer a final opportunity to compare the behaviour of interstellar ices with those found in local comets. Even faint data remains valuable. Every measurement contributes to a more detailed understanding of planetary formation in regions far beyond our own. Dust once abundant in the central coma now disperses into a thinner, more transparent halo. The tail narrows, losing the soft spread that characterized its earlier activity. Larger particles remain visible longer, while finer grains fade into the background sky. This process reveals how mass distribution changes as an interstellar body cools. The fading tail becomes evidence of a structure shaped by time, temperature, and distance, an echo of the heating cycle it experienced during its brief encounter with the inner solar system. Through these lingering particles, scientists trace the final breaths of activity before the comet settles into long interstellar quiet. The ion tail, once reactive to every shift in solar wind, now responds more subtly. Solar particles still flow across its path, but with lower levels of gas productions, the tail becomes thin, stretched into faint filaments, barely distinguishable from background noise. Yet even in weakness, it provides insights into how charged molecules behave in low-density environments. For a short time, these observations help refine models of interactions between interstellar objects and the solar wind. Soon, however, the signals will fall below detection thresholds, marking the end of the comet's electromagnetically expressive phase. Far from being a moment of loss, this fading becomes a form of closure. A comet brightens peaks and then recedes a rhythm as ancient as the solar system itself. Interstellar visitors follow the same cycle, though their arcs span far longer distances and far older histories. Watching Thriatlas decline allows observers to appreciate the continuity between local and interstellar materials. Despite coming from a different star, the visitor behaves according to the same principles. This reinforces the idea that the physical laws shaping our world extend seamlessly into regions we cannot reach. Uniformity across such distances becomes its own form of reassurance. Attention now turns toward trajectory refinement. During departure, astronomers gather positional measurements to improve the accuracy of long-term orbital models. The more data collected, the better they can determine the direction from which the visitor arrived, and the direction in which it will leave the solar system. These vectors, though abstract, hold profound meaning. They represent the path of a body-shaped light years away now weaving through our region, before returning to the silence between stars. The refined trajectory becomes a historical record, coordinates marking the object's brief intersection with our sun's gravity before it resumes its ancient journey. This work extends beyond simple documentation. By studying the trajectory and final velocities, scientists estimate the conditions under which the comet was ejected from its original stellar system. Such ejections often occur during the chaotic youth of planetary formation, when gravitational interactions scatter debris outward. A close encounter with a giant planet, a collision among early planetesimals, or the shifting mass distribution of a young star can all cast objects into interstellar space. To examine such a visitor now is to study the aftermath of events that happened millions or billions of years ago, under a distant star's early light. The comet's retreat also reveals the limitations of observation. As distance grows, signals weaken, detail disappears and images blur. Even the largest telescopes eventually lose the ability to detect the nucleus. Before long, the visitor becomes indistinguishable from the countless faint objects drifting through the outer solar system. And then beyond that, it fades entirely into the unseen. This is not failure. It is the natural boundary of observation. Every encounter with an interstellar object contains within it an acceptance that we witness only a moment of its existence. The rest unfolds beyond reach. Yet within these limits lies a quiet beauty. The fading teaches humility. It reminds us that not all knowledge is complete, nor must it be. Some understanding comes from presence, rather than permanence. To witness the passage at all is meaningful. To learn what we can in the time available is enough. The comet's departure becomes a gentle lesson in the nature of connection, brief, delicate, shaped by timing rather than certainty. Its motion demonstrates the galaxy's immense scale and our small place within it, yet also affirms that even a passing moment can carry value. As 3i Atlas moves outward beyond Mars and eventually toward the realm of Jupiter's orbit, its activity quiets to the point of near dormancy. The sun becomes dimmer, the heat insufficient to sustain sublimation. The nucleus grows colder, wrapped in a shell of dust that insulates its interior. It transitions from an active object to a silent wanderer, and as it proceeds farther still into the outer regions of the solar system, instruments fall away one by one, no longer able to register its presence. The story becomes memory preserved in data, sets, images, and the reflections of those who watched. No dramatic events occur, no final burst of brightness, no unexpected deviation. The visitor simply continues in the direction dictated by the physics of its entrance, and we, bound to our orbit around the sun, watch it depart until the sky claims it once more. Tonight the universe whispers again, softly, steadily reminding us that not all encounters are meant to last. Some simply pass through, illuminating our understanding for a moment, before carrying their silence onward into the deep. As the comet moves deeper into the outer regions of the solar system, the observations that once felt abundant begin to thin. The data streams slow. The radiant signatures that defined its earlier stages weaken to a faint murmur. Now the visitor enters a realm where sunlight softens and activity falls almost entirely silent. Yet even in this dim phase, the retreat offers insights that sharpen the scientific record. The rate at which brightness declines becomes a final clue about the internal composition, revealing how deeply heat penetrated the nucleus during its brief encounter with the inner system. Astronomers now focus on positional measurements, extending the observational arc as long as possible. Each new coordinate refines the trajectory that will ultimately describe the comet's exit from the Sun's influence. These refinements hold value long after the object disappears. They allow scientists to trace its origin vector with greater accuracy, offering subtle hints about the region of the galaxy from which it came. Though the precise birthplace will remain unknown, the narrowed directionality becomes a kind of cosmic footprint, a directional memory of a journey across light years. Meanwhile, the comet's physical presence continues its slow transformation. The coma once broad and diffuse contracts into a thin layer of refracted light surrounding the nucleus. The tail, nearly depleted of fine dust, now appears as a faint line, or vanishes entirely in moderate telescopes. These changes do not signal decline in the dramatic sense. They simply confirm that the comet has returned to a dormant state, preserving its remaining ices for the long voyage ahead. What was briefly illuminated becomes wrapped again in shadow, shielded from further erosion, until another star one day stirs its surface. For scientists, the fading is not a loss but a transition. The measurements taken now require longer exposures, sharper calibration and patience, yet each successful capture strengthens the dataset. Observatories continue comparing brightness curves with earlier models, noting how predictions align with reality. Differences remain, but these mismatches form the groundwork for future understanding. In astronomy, incomplete data is not failure. It is the foundation for the next generation of questions. The comet's departure also encourages reflection on the structure of interstellar space itself. As 3i Atlas moves beyond the orbits of Mars and Jupiter, it enters regions where gravitational influences weaken, and the boundary between the Sun's domain and the galaxy's broader environment begins to blur. Here, the visitor becomes a symbol of how permeable those boundaries actually are. The solar system is not a sealed sanctuary. It breathes welcoming objects from distant stars and releasing its own material outward through gravitational scattering and stellar interactions. This recognition influences how scientists think about cosmic exchange. The path of 3i Atlas is not an anomaly, but part of an ongoing flow of interstellar debris moving between stellar systems. Each visitor offers a glimpse into the environment surrounding other stars, carrying samples forged in places humanity cannot reach. These crossings reveal a galaxy built not of isolated worlds, but of continuous circulation, where material drifts freely and encounters occur naturally across millennia. As the comet continues outward, conversations shift toward the role such objects may play in shaping our understanding of planetary formation. The chemical ratios detected in its coma reflect the ambient conditions of a distant ancient nebula. The structural resilience that allowed it to survive perihelion provides clues about how planetesimals coalesce under foreign suns. Long after the object disappears, its data will inform theories about how solar systems emerge, evolve and disperse material into the interstellar medium. Public interest, though quieter, now follows its own rhythm. For many, the simple knowledge that an interstellar body passed this way offers a moment of perspective, a reminder that Earth is not isolated but part of a much larger environment. Though the comet no longer glows brightly enough to capture widespread attention, the imprint of its passage remains in the conversations and reflections it inspired. The event becomes a gentle reminder that cosmic moments do not need intensity to resonate. Sometimes significance lies in the subtlety of what passes through, unnoticed by most yet deeply considered by those who choose to look. In the final stages of visibility, the comet becomes almost symbolic, an emblem of transience on a scale far beyond human experience. Its steady retreat mirrors the natural rhythm of cosmic events, brief intersections followed by long separations. Nothing in its behaviour suggests finality. Rather, it simply returns to the path it has followed for millions of years. The solar system becomes a brief pause, a momentary illumination before the visitor resumes its quiet pilgrimage through the galaxy. Tonight the universe whispers again, not through brightness or motion, but through the soft recognition that some encounters exist only long enough to remind us of the vast ongoing story unfolding beyond our skies. The passing of the comet leaves no noise, no disruption. Only the widening of perspective and the calm acceptance that comes from witnessing something older than the sun continue its ancient path into the dark. As the comet slips farther from the sun's warmth, its retreat shifts from an astronomical event to a meditation on distance itself. What once blazed with ionized light now dims into a point that barely stirs the sensors tuned to track it. Yet the fading does not diminish its meaning. In this stage, its silence becomes the message. The long arc outward reminds us that most of the universe moves without witness, carrying stories across spans of emptiness, where only gravity and radiation serve as record keepers. Here the comet begins its slow return to obscurity, and in doing so reflects the nature of all transient things. The weeks following closest approach pass quietly. Telescopes gather what final data they can, stretching exposure times, layering images to capture photons that slip through the thin veil of cosmic dust. What emerges from these efforts is less a portrait of the comet itself, and more a study in endurance, how an object from another star system maintains cohesion after a rare dive into the sun's influence. Each faint measurement contributes to a larger archive evidence of how far human curiosity can reach when guided by patience rather than urgency. This is the phase when astronomers shift from observation to reflection. They compare earlier models with the updated brightness curves, analyse the decline of activity, and examine subtle deviations in the trajectory that might reveal outgassing or rotational shifts. Yet even here, in the realm of careful calculation, something more contemplative arises. The comet's retreat mirrors the nature of knowledge sharp at first encounter, fading with distance, requiring effort to maintain clarity. What remains is shaped not only by data, but by the quiet humility of knowing that most of the universe will always lie beyond our reach. As the comet passes beyond Mars and into the colder expanses, instruments detect fewer signals. The coma collapses into a thin envelope. The tail, once stretched by solar wind, dissolves into darkness. It is a return to the state in which it drifted for uncountable years before entering the sun's domain. That return carries a kind of symmetry. Objects that come from far away rarely leave changed in ways we can see, yet they shift the perspective of those who watch them pass. The comet continues unchanged, but the observers do not. For those who followed its journey closely, the fading marks an inflection point. The awe once sparked by images of its luminous tail now yields to quieter questions. What conditions shaped it around its original star? How many similar travellers drift through the galaxy unseen? What does it mean for material born in one system to pass through another, leaving traces of its chemistry in the spectra we capture? In these questions, the comet becomes less an object and more a bridge linking distant worlds through the physics that governs them all. In time, the comet will enter regions where only the largest instruments can follow. Beyond the orbit of Jupiter, it becomes a whisper in the deep, its reflected sunlight too faint for all but the most powerful telescopes. Yet even then, its path remains predictable, a testament to the reliability of gravitational laws that operate across light years. There is comfort in that predictability. The universe may be vast, but it is not chaotic. Even the faintest visitor obeys the same principles that keep planets in orbit and stars bound to galaxies. Eventually the comet will reach the threshold of true interstellar space. The sun's pull will loosen until it becomes indistinguishable from the gravitational tides of nearby stars. At that point, the visitor becomes what it has always been, a wanderer shaped by forces older than our solar system, continuing a journey that neither began nor ends here. It will drift into regions where human instruments cannot follow, carrying the silent imprint of its passage through our small corner of the galaxy. The departure of the comet leaves behind no shockwaves, no visible trail across the night sky. Instead, it leaves a realization. In witnessing something that travelled from beyond the sun's influence, we were reminded that we too inhabit a position between movements far larger than ourselves. Our curiosity, our questions, our pauses beneath the night sky, all become part of the quiet dialogue between humanity and the cosmos. Silence is the universe thinking, and in that silence we find space to reflect. Somewhere beyond our reach, something ancient still moves. And as this visitor slips back into darkness, it leaves a final lesson. It's all right to not understand. Dreamer. We've reached the quiet edge of the story where the noise of certainty fades and only the slow pulse of the cosmos remains. 3. I. Atlas continues its long outward drift, now following a path older than our sun, carrying with it a silence that reminds us how brief and bright our awareness truly is. And yet for a moment we crossed its trajectory with our attention. We noticed. We cared. In the vast arithmetic of space, that small act is not insignificant. December 19th will arrive like any other date on the calendar, but beneath it lives a rare alignment, a visitor from another star system passing close enough for us to witness its passage, far enough to remain untouched by anything but wonder. It asks nothing from us except the willingness to look up even once and feel the scale of what surrounds us. The universe will continue whispering in its own language, radiation gravity, the soft dimming of a comet's tail. Its stories will outlive us, but tonight you shared one of them. Rest well, dreamer, stay curious, and if this story found you tonight, you may stay for the next.